Okay, let's take a look at finding the nth term in an arithmetic sequence. So we have a sequence here, and we can determine what the common difference is. So 4 minus 1 is 3, 7 minus 4 is 3, 10 minus 7 is 3. So our common difference is 3. And we can see this is the first term, second term, third term, fourth term, fifth term. If I said, okay, what's the sixth term? Well, the sixth term would be 16. The seventh term would be 19, etc., etc. But now if I ask you, okay, well, what about the 10th term? Okay, you can still figure that out. But what if I said, what about the 100th term? So what we want to do is we want to figure out a formula so that we can find any term, no matter what what term we're looking for, as long as we have the sequence. So in this case, we have the first term, which we already know, as a sub 1 is 1. And then we also figured out that the common difference was 3. So if we're given the first term and the common difference, it's going to be a sub n equals a sub 1 plus n minus 1. And that 1 is designates the fact that we're looking at the first term, and then times d. So that's the form that we use. If we look at this sequence that we were given here, and we say, okay, well, let's use this formula to find we're going to use this equation, this formula, this function, to find what this sequence would be. We would do a sub n equals the first term, a sub 1, which would be 1, plus n minus 1, again, because it's the first term, and then times 3. Now, we're not going to leave it like this. If I haven't mentioned already, a arithmetic sequence mimics a linear equation, so we want to show it in slope-intercept form. So a sub n equals 1 plus 3n minus 3 equals 3n minus 2. So a sub n equals 3n minus 2 is the equation, the function, I should say, that represents that sequence. Okay, and next, if we have two terms, but we don't have the first term and we don't have a common difference, and we have two terms, they're going to be a sub m and equals some value, and a sub n equals some value. If we have those two terms, it's very similar to this function here. We're going to go a sub n equals a sub m plus n minus m times d. And the a sub m will always be a term previous to a sub n. If we want to find what d is, so let's do this. Let's just pick some. Let's go pick some random numbers here. Let's go a sub 5 equals I don't know. Let's just say 8, and then a sub 7 equals 14. Okay. So we have two terms. So we come down here and we say, okay, well, I'm sorry, getting back to D. So to find D, D is ultimately it's the slope of our linear equation. So to find D, if we have just two terms, we're going to take a sub n minus a sub m divided by n minus m. So in this case, it would be 14 minus 8 divided by 7 minus 5. 14 minus 8, 6, 7 minus 5 is 2, so 3. So in this case, D equals 3. Then we can come back up here and we can say, okay, well, a sub n equals a sub m, which is that piece there, 8 plus n minus m, which is our 5, times d, which we determined was 3. So we have a sub n equals 8 plus 3n minus 15. So a sub n equals 3n minus 7. Okay, so hopefully that makes sense. Let's quickly look at a couple of these. So find the formula for the nth term. Well, 4, 4, 4, 4. So D equals 4. A sub n equals a sub 1 plus n minus 1 times D. So let's put those values in here. So a sub 1 is 2. And then D is 4. So a sub n equals 2 plus 4n minus 4. So a sub n is 4n minus 2. This would be the formula for the nth term of an arithmetic sequence. This sequence, that's the formula for the nth term. Okay, come over here. We have a sub 1, we have the first term, and we know what our common difference is. So a sub n equals a sub 1 plus 1 minus m times d. A sub n equals 5 plus, carried away. And minus 1. So, n minus 1 times our d, which is negative 4. A sub n equals negative 4n. Let's see, that's going to be 4 plus 5 is plus 9. Come over here, last couple. So if we want, let's first find D. D equals 42 minus 26 divided by 12 minus 8. Let's do this. 42 minus 26, and then 12 minus 8. And that's going to equal 4. Now again, we don't have the first term. Okay, we have the 8th term and the 12th term. So we're going to go, here we're going to say a sub n equals, we're going to go a sub 8 plus 8, plus n minus 8, so not n minus 1, n minus 8 because we have the 8th term, and then times 4. To a sub 8, we know it's 26. So we say a sub n equals 26 plus 4n minus 32. Again, we're going to simplify that. A sub n equals 4n minus 6. Okay, and for the last one, very quickly, a sub n equals a sub 1 plus n minus 1. A sub 1, n minus 1 times d. So first thing is, what is our a sub 1? 15 plus n minus 1. And the question is, what is our d? Well, if we look at this, we say a sub k plus 1, which is going to be the term after a sub k, right? So if a sub k plus 1 equals a sub k plus 4, then 4 is our d. So we put 4 in here. And then we have a sub n equals 4n plus 11.